Greetings, the Astro 30 here, and today's little project is to build this in-circuit transistor tester, which is a kit KA1119. This is an old Electronics Australia project, goes back to September 1983, that's how old this thing is. Now this actual kit that I bought from JCar today for, I think it was about $30 odd, wasn't that expensive. Obviously, it's not that old. It wasn't assembled as a kit, like in kit form, since 1983. It's just that that's when it was published. Now, the thing is, Electronics Australia as a publication doesn't exist anymore in Australia. Silicon Chip Publications actually bought them out back in the late 90s, early 2000s. Can't remember the exact date. Anyhow, that's beside this point. This makes this, what's that, 83, 93, 2003, 2013, well over 30 years old. So it's an old project. Now, why would you use an in-circuit transistor tester? Well, as it says here, have you ever desoldered a suspect transistor only to find that it checks out okay? Yes, I have. See, the thing is, if you use your standard multimeter here, like this one, on your diode test scale, what that's doing is it's applying a small voltage in the order of a few millivolts to the base of the transistor, and that go either to the collector or the emitter to test for conductivity there. So that actually turns the transistor on via that small millivolt voltage and allows current to actually flow through either the base collector junction or the base emitter junction. Now that's fine, but what happens if you've got like a resistor going across the base and collector, and it's like with a small value, say, I don't know, 100 ohm, something like that, something silly like that? Well, you're actually going to start measuring the actual resistance value across that resistor. So you'll end up with a, say your normal transistor test is, say, 600 to 800 when you read it on the multimeter screen, and then you put it across this 100 ohm resistor, which you don't know is there at the time. You end up with 100 and you think, oh, hang on. So you reverse your probes around and find that it gives you the same reading in the other direction, which it shouldn't. So you indicate to yourself, like, oh, this must be a bad transistor. Well, no, there's just other parts in the circuit to consider. So this eliminates that problem. You don't have to unsolder the transistor from the circuit. You do not have to actually know anything about the circuit except the transistor you're looking at. So we'll get the kit open and we'll have a look at the instruction manual and possibly the schematic here, just to see relatively how it works. Now, this is what they call a full form kit. That is, you get the case hardware. They even include a nice 9-volt battery, which I'll just stick across my tongue. Yeah, it's a little on the flat side. I should stick that on a multimeter and just see what we've got as a battery voltage in that. Don't know if you can see that, but it says 9.52, so yeah, it's charged to a point. So anyway, moving on, we also have, this was the days of old electronics kits. You'd actually have to stick stickers to your panel work here, and yeah, see, the thing is, nowadays they have pre-punched and pre-silk screened kits. This one, I've got to stick the sticker to it and actually drill the holes necessary. But we'll put that aside and get to that later. There's the components with a relatively small circuit board, so it's not an overly complicated circuit. I like that handy tester. Just as I thought, without really reading the circuit description, they're using two 555 timer ICs, and one would be configured as an oscillator, so it would be putting out a signal to one of the test leads as probably a square wave, which is a better way of testing a component like a capacitor or a transistor in this case in circuit, is by not applying a direct voltage to it, but rather a pulse width modulation to it. So I reckon it's configured as a PWM. And of course, I didn't even read this part over before I said that, and basically it confirms what I said. The circuit is basically a 2 Hz oscillator with complementary outputs. If it tests transistors, diodes and SCRs at the press of a button. This circuit is basically an oscillator, as I thought it would be, which provides a PWM signal on the output to the device that you're testing, rather than a voltage, because doing it with like the multimeter, in the case of a multimeter, you're putting a small millivolt voltage out onto the component you're testing, which can give you false readings, as I previously stated. So the circuit is pretty simple. It's nothing all that overly complicated. It's just basically a 2 Hz oscillator. So construction wise, it's not going to be that difficult, but I would start with the circuit board first, because that's obviously going to be the easiest thing to do. The hardest thing is going to be doing the hardware here. So yeah, it looks like I only have to drill 3 holes, one here for the test button and 2 here for the 2 LEDs that poke out through the case. But I'll check that in the instructions, because I'm not sure what that's for. It might be another hole, might not be, but I don't think these have to be drilled out. That's just a truth table. It tells you what each of these indicators, when they come on, means. For instance, if the first indicator comes on, you've got a NPN transistor, and if the light comes on, it's obviously good. If the second light comes on, it's a PNP transistor. Now, if both lights are off when you press the test button, that means that the device that you've got there is short-circuited, because S/C here, short circuit. If both lights are on, it means the device is open circuit. And again, if the first light is on, it's an SCR. And if the second light is on when you measure across the anode and cathode that way, that's actually printed backwards. That should be the anode, that should be the cathode, according to the symbol. So they've actually printed that wrong. So if that light's on, that's the direction of the anode, that's a diode. And if that light is on with the diode around the other way, the anode's over there. So it's not really that complicated a tester. Up here is just a little table to tell you what colour wire, test lead, to connect to what pin. In this case, collector, base, emitter, so red for the collector, green for the base, and blue for the emitter. So you still need to know the transistor you're testing, its pin out. Or you use red for the anode and blue for a cathode on a diode. And for an SCR, you've got a gate as well, so just keep that in mind. So that probably means I'm going to have to drill a hole out the back here for the test leads to pass through. So all in all, I'm not really happy about that part of it, but it is what it is. At least plastic's easy to work with. So I'll be working with this circuit board first. They do say on the box that you've got to provide your own battery holder, and it does say some casework required. Now I've lost the battery holder. That's because I left it on the bed in the other room. This is a 9-volt battery clip. It just holds the battery into the device that it's mounted into and stop it flopping around. This was like about 90 cents. It does have a screw hole connection, but the problem with putting screws and bolts or nuts and stuff through here is it tends to make contact with the battery. I mean, you can put a piece of foam in there if you want, but I might just in the end just hot glue this into a good position inside the plastic case once it's all assembled, so it stops it flopping around. And how the circuit board is going to mount in the front, or into the case, is going to be a Another good question, but I'll read the construction instructions first. And so, but basically I'm going to start with soldering this board, as I've already said, and to save waffling on any further, I'm also going to use the original tip that came with this T12 soldering iron, which is a BC3, I think it is, I can't remember offhand, instead of the BC1, because I heard that the BC1 has an internal resistance to it, so it actually lowers the heat, because this is designed for light work, and this being a sort of like a drag tip is designed for heavier work. So I'm going to look around for a better tip with a pencil point on it that doesn't have internal resistance. Now you can hear that rattle inside the soldering iron. That's the shake detector. That indicates to the device that you've picked the soldering iron up. It comes out of sleep mode or off mode even, and is now ready to do some work. See? So that was what that funny looking component when I was assembling that was. That's the shake detector. Without that, well, the unit will go off and it won't come back on when you pick it up, because this goes into limited temperature mode first and then goes completely off after a certain period of time. Before construction begins, I've just been reading the construction details, and it says in the first paragraph that JK Electronics have revised the printed circuit board so that all components are now mounted onto it. The new PCB for the project is coded blah blah, only measures 57 by 70, only a few minutes work will be needed to solder the components in place, but watch the orientation. All the components except the resistors are polarized, obviously. In particular, watch the orientation of the LEDs. As explained earlier in the text, unless they are wired with reverse polarity to each other, they could be damaged. Anyway, basically the circuit board is mounted to the inside of the cover of the case. This would be the top, that's the bottom, via the two switches and a 9mm standoff, they say, and a washer. So the total amount of holes you need to drill in the case is 5, and you also need to put a hole in the edge of the case for the test leads to come out with a grommet. But we'll get to that later. So the first thing I'm going to do is I'm going to start assembly by installing the resistors. There's not many of them, 5 by the looks of things. There's 4, probably 1N4148s. Indeed there's 4 of them, and the 2 NE555s and some IC sockets for it. You don't really need IC sockets for the timer ICs, but well, I'm going to use them because they're there. Now they provide me with these standard 5mm LEDs, which is, yeah, okay, but I might want a little bit of pizzazz. Now these take a 5mm hole, but I do actually have some blue LEDs which I might use instead. I don't know. I'll get to that when I get to that. But first I'm just going to install all the components on this circuit board. It's all marked on the silk screen. You've got one switch which mounts to the board here. I can't see any other switch. There should be a test button somewhere. Yeah, the test button there, that's also a switch. So yeah, the 2 switches mount here and here. One's a DP-DT and the other is a push button. So I will start with the resistors and then I'll move on to the diodes, finally the capacitors, but I'll leave the LEDs till last. Oh, just one thing to note, there is a link wire here that's got to be installed. Actually 4 in total. There's one here, one there, one there, and one there. So I might start with the link wires. I'm just going to use my roll of tinned copper wire, 0.7mm, whatever it is. Yeah, 0.71mm to do the links. Okay, now I'm doing the link wires. I'll just see how good this solders with this other tip. Not bad. I honestly think it's roughly the same. This kind of is the wrong tip for the job, I must admit. But yeah, I wasn't going to pay $60 for the soldering iron kit and not use it. So yeah, it's useful for some things, just not heavy gauge work. I'm actually going to load all 5 resistors into the board at once, just to save the amount of times I've got to turn it over and solder and then cut off leads. So that's 1470 there. Where's the other one? Up there. And I'm putting them bands all the way around the same way so the electrons don't fall out. Finally, we've got this other resistor here, which is a brown, grey or silver, black, orange. A brown, grey, black. That's a 180 with an orange, which is 3 zeros. That should be 180k. Hey, I can read resistor color code still. There it is there, 180k. Upside down to you, I'll turn it the right way around. 180k. As I say, these 5-band resistors can take a little bit longer to work out just by reading the codes, but I could have measured it and saved myself some time, but I didn't. So put that 180k in. Now I can turn him over and solder the components in. Now I don't really want to make this video too long with construction, but yeah, I've only been recording for like 7 minutes, so once I edit it down it will be a little bit different. Okay, that's the 5 resistors, and that went shot off somewhere. That's the 5 resistors installed. I can now move on to the diodes once I can pick these offcuts off at the desk. There we go. I can move on to these 4 1N4148s. Now just keep an eye on the orientation of the said diodes. Okay, that sponge has gone really, really hard. Alright, so that's that done. Next I might mount the 2 IC sockets for the 555 timers, taking note of where the notches are. They actually face each other, so they're one's put in reverse direction than the other. So because I've done all the lower profile components first, I can now do the larger profile components, and I'm just bending over each opposite pin of the IC socket just to make it easier, and it holds it in place while I solder. That joint looks like crap. Looks a bit better now. Okay, so that's the IC sockets installed. Now we have 2 capacitors to put in, a 10 microfarad and a 1 microfarad. If you look at the board here, you'll notice that there's a long square part past the capacitor. That means you're actually laying the capacitor, or the correct way around, capacitor down against the board, because don't forget this has got to come up against the front panel, and you've only got probably the switch itself will be about that height. So that's the reason why you are going to lay the capacitors down at right angles, so one here and one here. There's a 1 microfarad over here, which is the one I've got in my hand. So what should I do now? Well, I might as well install these ICs. I still haven't bought an IC inserter tool. I will eventually one day. Insert them like that. And just for verification, make sure they are 555 timers and not something strange. 555. 555. Yep, they're any 555Ps. I mean, when you think about it, they could have used a 556, which is a dual 555 timer, but they chose not to. Now, with the LEDs, I'm going to leave them to last for the reason why I said I've got to change them over to something different, but you've also got to line it up so it comes through the front panel properly. You can't just solder them in and hope they pop out the front right. So you want to actually mount the board with the LEDs loose, like, you know, that, and that, so that you can move them up or down, and then when you've got it sticking out the front panel just enough where you want it to, you can then turn it over and solder it. So I would leave the LEDs well to last. Now I need the two switches, because that's the next thing I'm going to install. That's my 9-volt battery clip. That gets soldered last. There's the wires for the test leads. Here's one of these test leads. Now, these are going to be interesting to assemble because I've never assembled one. So, I'll have to look into that. So they've given me two red ones instead of a green one. Well, that's handy. Nylon standoff, threaded. The rubber grommet for the test leads. Screw and a washer, plus another screw that's got a countersink to it. A bit of solder, which I'll keep for something else. So this is our DP-DT. Now, it doesn't really particularly matter which way around you put this thing. It's just going to be awfully difficult to get it to solder straight in the board. Same with this push button switch. It doesn't matter because all these bolts, these nuts, they pass through the top of the front. So you don't have to mount them first to the panel and then solder them to the board or anything silly like that. So getting them to stay straight while soldering might prove challenging. Now, all this switch is used for is to change it over from transistor test to diode test. That's all it's for. Now that joint ended up cold. Don't know why. Right, so that's all the switches mounted. That joint looks awfully strange. I don't know if you can see it, but that joint looks weird. It just seems to constantly, when it tries, look like that. Okay, so that's the construction. Ow, that was hot. That was the construction of the main board done. The switches are in. Everything, that's got some heat going through it. Everything's on there but the LEDs, as previously explained. I do need to connect the 9-volt battery clip and, of course, the battery, test leads. But first, I think before I go any further, I'm going to actually start looking at my enormous penis, doing the hardware. So just going to open the Jiffy box. That didn't exactly work. Try knife might work a little bit better. The Jiffy box they're using is a HB 6013, which should be included in the kit. That's our front panel artwork. I'm just wondering, I'll open that. Yeah, it comes off separately of the edges here, so it goes around the screw holes. Okay, that's all I was interested in. And all of these other holes you got to drill, they should pop out of the panel of the artwork here, so you've got a hole to drill through. It does say in the instructions not to actually stick the label to the case first. It even comes with 4 little rubber grommet things that you put over the screw holes as feet by the looks of things. Nice. But the way I've got to assemble this is, well, this mounts to that, not really to that. So they say not to put this on first, but frankly, it's going to make life a lot easier if I do. So I'm just going to line him up as best as I can by eye. There we go. And that was actually pretty straight. Now, because this is plastic, having this on the panel first before drilling isn't going to make that much difference. There's not going to be like heat getting into it. I need to drill 4 holes basically, 2 for the LEDs and 2 for the switches. So you don't really need to see me doing that. Oh, there's another one over here for the little standoff. So yeah, you start with the smallest drill bit, try and get it as central as possible. I'm going to start with 1mm. Drill out the holes to the correct size after you've finished, and then just, you know, test fit your board as you're going, just to make sure that the holes are the right size. So I'm going to do that now, and yeah, I'll come back when I've done that. Okay, just going to change to a 3mm bit now. Okay, the 2 LED holes I'm going to leave as 3mm. Didn't burn too much on the other side, that's good. Now I just need to drill out these 2 holes, which I believe are 6.5mm each. Might be a bit big for 6.5, so I might try 6 instead. That should be pretty much more close to where I need to be. That's one reason why they say not to put the label on first, but yeah. Okay, now let's see if that will fit the switches. That's the test switch. Nope, 6.5 was about right. I'm not too worried about it damaging the label here at this point, because the mounting hardware will cover that. Now, let's see if it fits now. That DPDT does, but that push button's still slightly too small. So just enlarge the hole a bit. Yeah, now it fits. Okay. That's the two main holes drilled. I guess the next thing to do would be to, well, install the 9-volt battery clip. They've already got pre-stripped, pre-tinned wires. My glasses have disappeared somewhere. There we are. Obviously the positive goes to positive, and that goes to the negative, the ground. Okay, that's the power sorted. And I could have run it through one of these holes, I suppose, to stop it stressing the leads so much, but I didn't. Now I just need these wires, because I'm going to install them next. Now I'm going to need some form of strain relief, I think, but I'll worry about that when I've actually got the wires installed. So I'm going to strip them off and put them where they go. Now it is marked on the front panel which one's which. So red is the anode, green is the base gate, and black is the E emitter or cathode. Okay, that's my test leads installed. Now I've just got to work out. So that hole over here is where that 9mm standoff goes, and we're using a washer and a screw, but it doesn't actually say where to put the washer. So for now I'm going to stick the washer and screw on the back of the board and apply this, and if I need to put it in between this and the board I will do that later, but for now I'm just going to put him in there, do the screw up, because this black M3 screw goes through the front, so it actually matches, well, the colour of the panel. And I'll get to this grommet hole on the side of the case a little later in this video, but for now we're just going to get things set up, wired and tested. So before I can actually do anything, I'm going to need to undo these mounting things, because I've got to pass it through the front panel. So I've got these two blue LEDs. These should be the same brightness and intensity as those two red 5mm ones. Shouldn't be that much difference in it. These aren't high intensity LEDs, so they should be right. I'm just going to check that the size of my hole is correct, which it is. Got a little bit of crap there. And I reckon that's going to look a lot nicer on the front of the panel than the big ass red LEDs. So I need to insert these in the board the way they go around. So I'll just start them off. Won't go all the way down, but it's good enough for now. So let's get them started, and I'll bring up this to the front panel. And all going well, it should be okay, but I've noticed a little problem. There's a little bit of difference in height between these two switches, so I need to take this second nut off, because otherwise it's going to sit at an angle. So it's not needed because both switches are roughly the same height in profile. So try again. That's a bit better. So the test leads will come out there somewhere. Battery lead can just go around somewhere else. That's fine. Board is a bit crooked. Really crooked. Now however, I'm just wondering, is that going to interfere with my standoff? It shouldn't. No, it should be just right. Okay, anyway, So I guess to hold things together, I will put this, after I drop it, this screw through. You don't need to over tighten it, just tight enough. Yeah, I don't like that. I would have used a flat screw myself. In fact, actually, that's exactly what I'm going to do. And I'm just going to go with one of these normal nickel plated, I think that's what they are, nickel plated M3 screws. Because otherwise I'd have to countersink the plastic hole, and countersinking in plastic by hand always looks like shit. So I'm just going to use a normal screw because at least it will not destroy the label too much. Get that relatively tight. Okay, I probably should have straightened the LEDs up first because one of them's bent over now. So I'll just I'm going to get the LED to pass through the holes, or the LEDs to pass through the holes. So they're passed through the holes now, that's better. Now I can tighten the screw, wrong end. That's tight enough. Okay, this is for that switch. Okay, so that's the test switch all put in. I wonder what happens now when I actually hook the 9-volt battery up to it. Not a great deal. Might help if I solder the LEDs in. So, alright, I don't think anything's going to happen when I hook up the battery and push the test button, but yeah, we'll see. Battery's in. Oh well, the lights light up, so I know that the brightness of those LEDs is fine, so using those two blue ones are perfectly fine. Look how it just oscillates back and forth like that, that's kind of cool. Anyhow, so I'm going to need somewhere to mount the 9-volt battery. So I'm thinking just there like that, in behind the circuit board. So I would take this component that I've got here, and your battery just holds in like that. It's going to be awfully tight and it's going to bend a bit, so it will conform after a while. So what I'm going to do is I'm going to warm up the hot glue gun, and I'm going to hot glue that roughly in the center there somewhere, just to give something for the battery to hold to. And there should be enough clearance in this case for the 9-volt battery, just like that. Okay, I believe the hot glue gun is hot enough, so I'm just going to squeeze out quite a fair bit of glue onto the metal and be quick with it. Stick it to the plastic lid like so, and just for good measure I might stick a little glue because I love this stuff, it's like hot snot, around the edges, or at least the edges I can get to, just to make sure it holds properly. And I believe that's all I need the hot glue gun for. Alright, that's nice and hard now, that's what she said. So I can plug my battery in and install it in the clip, like so, and that'll hold it in there nicely, all the way down. So just make sure that the cables aren't going to interfere with each other, and then it will go together like that. But first I need to drill a hole in the face of this box here to pass the test leads out. Now I'm not sure what size hole I'm going to need. It looks like around about 9mm. So I'm going to go do that and then I'll come back. So I'm going to use this 4mm to 12mm stepper bit because I don't believe the diameter, inner diameter of that's any more than 10. I've done a 6.5mm hole, just guessed where it was going to go. Not overly critical. So I'm going to step it out until the grommet fits. Alright, let's go. That's about 10mm, so that should be about the right size. Indeed it is. That fits in there just nicely. Just got to go through all the way through. There we go. That's it. So it's a 10mm hole and that's all you need for the grommet. Okay, so next I'm going to need a strain relief in these wires here, so that when you pull them from the outside it's not going to, well, break the connections on the circuit board or bust the circuit board, which you shouldn't. So I'm just going to tie a knot in these wires, all three of them together, somewhere around about there. So now I can then pass my wires up through the grommet and you can't pull them out. So now I'll just put the two halves of the casing together. Yeah, I believe that circuit board is interfering with the case because it's not straight. So the way I'm going to fix that is I'm going to probably heat this switch up so I can just gently rotate the board around at a slight angle. I only need an extra millimeter or so. So I'm just going to heat the test switch, which is now activating the LEDs. So I might just disconnect the battery. Might be a good idea first. Okay, so rather than trying to maneuver the board, I probably should have thought about this a little bit better before I did it, but I'm going to take a file to the edge of this board and slightly take the corner out of it so that it will just slip past the mounting post a little better. I don't have to take off much. Okay, and being a fiberglass board, I just simply cut a little bit off the edge there with the side cutters and then fold it a bit smoother, and it now fits together relatively easily. So, see, now it fits together with little to no effort. So now I can plug the battery back in the correct way around and put this back on together. Yep, circuit still works. Now I can put the screws in to hold the casing together. There we go. And by the way, if you ever strip a plastic hole in a case like this, you can just simply put some super glue down the thread and that'll make it bite, or the screw bite a little bit better. Now, either I'm doing this wrong, I might be doing it wrong. Yeah, I'm doing it wrong. These do actually act like feet, but they also hide the screws, but it's pointless when it's coming through the top like this, but they're tapered. So the taper actually goes into the hole. So the larger area of the stopper is facing outward. And I'll do that on all 4 sides. And wasn't all that difficult. Now I've got to do these test leads. Now, as I said before, I don't know how these work, how you're supposed to use them. So I'm going to have to read the construction instructions to see if it tells me how to do it. Alright, I've just figured out these actually come apart. So there's where the wire has got to go. So you would solder that. These are called easy connectors. So you pass your wire through the thing you push first, obviously, and then you just solder it to that pin there and then put the whole thing back together. So I'll put my button on, whatever you want to call it. Just strip the end of this wire. I'm going to pre-tin him. I think that tinned. Okay, and I don't think it particularly matters which way around you get this. So pass it through the eyelet, and I'm going to try to bend him into a little hook. And I'll use the side cutters to hold that still whilst I solder that into position. And that's that one complete. Pull this back over the lead, line it up because it's got to come out like that, and then just simply push the 2 halves together, maybe. It does matter, that's got a little groove in it which has to line up with the groove in that, but it will still work this way around. There we go. And one connector done. So I have to do that with the other 2. Okay, now they say in the testing procedure here, to check it out you just press that and those 2 LEDs should flash alternatively, which it does. And that's with all the test hooks disconnected. Now you would short the EK and CA leads together, which is the black and the red. So I'll take the black and the red and put them together, like so. Then you press the button again and the 2 LEDs should now be extinguished. Nothing happens, so that's correct. So we know that that's working. I don't know what happens if I put the green and the red together, flashing alternatively. What about the green and the black? Flashing alternatively. Okay, so we know it's working. Now we need to hook it up to probably a transistor and see what happens. Okay, I've got a 3904, that's a 2N3904. So that goes with the front facing emitter base collector. It's the opposite of a BC series. So the black is the emitter. I know this is testing it out of circuit. Green is the base and red is the collector. So I'll connect it like that, press the test switch, and it's flashing on this one, which is NPN. So that means that A, it's an NPN transistor, and if it's flashing it means it's good. So if I reverse the emitter and the collector just to see what happens, like so, and then press the test switch, it still works. So it really doesn't matter if you get the collector and emitter inversed, but what say we get the collector and the base inversed. So I'll swap them around. funnily enough, it still works. So it doesn't really care. So that's an NPN transistor. Now I've got its counterpart, the 3906, which is a PNP, a 2N3906. That's the base. Red is the collector, and black is the emitter. Push the test switch and this LED should flash now, which it does. So that's telling me that that transistor is good. So I know that this works, and works quite well. So what about diode test mode? So I would only need the red and the black wires. This is a 1N34A, which is a germanium diode. So the black is the cathode and the red is the anode. Push the test switch and it's flashing, letting me know that the diode, yeah, it's letting me know that the diode is, the red is the A and the black is the K. So it's flashing right. So if I reverse these around, it should tell me, well, that one should flash, which it does. So I know it's now reversed the other way around. Now how about shorts? What happens when you've got a short circuit? So I'm just going to connect a jumper lead across the diode. Nothing happens, it won't light up. If it was open circuit, it's just going to do exactly the same thing as it was when I was first testing it. Both lights are going to flash like that, alternatively, meaning you've got an open circuit. So yes, it does work. It works quite well. So how about with something in circuit? That's going to be a little bit more challenging to find. This stupid radio kit that I've been abusing the hell out of, it's good for doing demonstration tests. Now that's a 9018. I have no idea if it's a PNP or a NPN, but I know the base is in the middle. And well, the tester doesn't really care, so I'm just going to connect it up any old how and see if I can actually do this. I think these leads are a little bit too close together to do this properly. Yeah, I've just shorted the thing out. Okay, move you up there somewhere. Oh, put it on the transistor test. It's saying it's an NPN, so that's in circuit with all the resistors and capacitors and stuff wired in, and it's still testing good. So I now know that that transistor is fine. Even if I disconnect one of the leads, it will flash like that, meaning it's open circuit somehow. Which is true, because the emitter is not connected. Because these 90 series follow the same pinouts as the T2N3904 and 3906. So that's the in-circuit transistor tester, and it works quite well. And I'm actually quite happy for what I paid for it, which was $30 odd from JCar. They're still selling it currently. I don't know for how long. It doesn't say discontinued on their website. But this sort of tool, or this test instrument, can prove to be quite invaluable when you're trying to fault find, say, a discrete power amplifier and you've tested your transistors with a multimeter but you're getting funny readings. This will, if you break this out, this will confirm whether or not the transistor is working. So anyway, I hope you enjoyed that video, found it useful. Yeah, thanks for watching. I'm the Astro 30, and if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and Twitter. The links are in the description as usual. Also, you can support me on PayPal by donating as little or as much as you want, because your donation allows me to buy stuff to play around with on the channel. And speaking of channels, check out this guy, 12 Volt Vids. He has some great content to do with electronics on his channel. Anyway, this is the Astro 30 saying see ya, have a great day.